Hi. In this video we'll go through some of the basic features of the Octane Scatter. Octane Scatter works at render time. It still got some limitation, but it's pretty powerful. Let's get started. So let's start with a new Octane default startup scene. I'm going to add a plane, rename it Scatter. Then I'm going to add a surface, rename it Scatter as well. Add a cube, and this will be our instance. I'm also going to add another plane that will be our surface. Now let's specify the scatter surface in the geometric node, and of course we have to add a scatter on surface node and attach it. Let's make it larger so we can read all the options more clearly. The scatter node should be attached to the displacement input, not to the surface, so let's do that, and then we can update and specify the node we just added. Let's hit the plus sign, so an object data will be added. We can specify the surface object. Let's do the same for the instance. Let's start the render, and let's adjust the lighting a little bit. Something like that. Okay. So now we are using vertices to instance our object. Something important we need to do is to select all the objects involved and select the Octane coordinates. Press the Alt key so the option is assigned to all selected objects. Now let's change the distribution to 1 instance per polygon, and we can see how triangles are used instead of quads. To get rid of this problem, just let's activate Open Subdivision, leaving the subdivision level to 0. Let's select the surface plane and go in edit mode and subdivide multiple times. Now let's select the instance object and let's transform it. We can rotate it, scale it, and move it, and the clones will not move because we're using geometry out. If we use the transform geometry output, then the scattered objects will respond to any transformation we're going to perform on the main clone. In this tutorial we're going to use the default geometry output, by the way. We can use several distribution methods: per vertex, edge, per polygon, random instance per relative area, or relative density. And in that case we need to specify the number of instances. Now in edit mode, let's scale down the instance object, and let's also increase the number of instances, and everything updates in real time. Now let's clone our instance. So we have another one, let's rename it, and let's make some small changes. We can now add this second object we just created. You can use up to 4 objects. Now both objects are used, and we can also change the object selection method. We have several options. We have like sequential, random, or selection map. Let's select the surface object again, and in edit mode let's subdivide multiple times. And now let's select the 2 instances, and we're going to use individual origins to scale those in edit mode. Now let's change the object selection method from selection map to sequential, and then random, and then back to selection map. Now we're going to use a noise texture to control where each instance should appear. Let's connect it to the object selection map input, and let's add a UV projection node. You can only use UV projection with scatter, and let's also add a 3D transformation node. Let's select those 3 nodes here, and let's make a group using Ctrl G. Now we can use this group to map the surface object. So let's just copy the group here and connect it to the albedo. Let's go inside, and yeah, we can change the gamma, the contrast, so we can see the mapping in real time. Changing the gamma and contrast of the noise texture can produce some really interesting results. You can change the octaves, but also the noise type. The noise texture node is pretty powerful and offers several noise types that can really help achieve different results. Let's select the scatter object again and change the distribution method to relative density. This is for sure the method I love the most, and let's increase the number of instances. The Poisson option makes the distribution more even, but it can slow down the computation speed a little bit. Octane Scatter is pretty fast, as you can see. We can make changes to the noise texture, to its transformation node, and everything is showed in real time. Right now, our instanced objects are aligned to normals. So let's make a copy of the surface object, and I'm going to just deform it a little bit, like this. And then I will use this as a new surface object. So let's change it to surface 001. Now you can see that the scatter has been updated, and we can now turn off normal align or turn it on. Also, we can choose smooth normals or not. You can see the difference here. Smooth on. Now let's go back to using the initial surface object. So let's select it here, and let's get rid of surface 001. Let's also make a copy of the surface object and put it aside like this, so we can use it to clearly see the mapped texture. We can now make some changes to the gamma. You can also invert the texture, why not? Change the contrast, and admire how the instanced objects are following the texture pretty closely. The Octane Scatter node, of course, is allowing us to randomize the transformation for the scattered objects. So let's start taking a look at how we can vary the scale. So if we select randomize with independent axis, the scaling on the 3 axes will be totally randomized, and we can decide the minimum and maximum values for that. If we use randomize with coupled axis, all the scattered items will have different sizes but the same proportions. Even in this case, we can choose to use a map to control the scale. So let's use the same noise texture we've been using till now, and yeah, let's connect it to the scale map and make some changes. More octaves, different gamma. And of course we can define the minimum and maximum limits for the randomization, still using the map to control the scaling. Pretty powerful. We can increase the number of instances, and still the update will be pretty fast. What we've done for the scale option can be, of course, done for the translation. So we can scale on all axes when using fixed, but we can randomize with independent axes or coupled axes. And yeah, translational step is an important option because it basically defines a step in the randomization. Very useful. For sure, playing with the various options in the scatter node is the best way to learn how to use it and to understand how useful it could be. And being able to use a map, even if we're limited to UV projection, it's really, really amazing. I love this option for sure. We can really do so much with it, especially considering that each parameter can be animated. So it is possible to create some very interesting dynamic effects. Each noise type really offers some unique look that you can explore, and changing octaves makes a big difference, and also playing with gamma and contrast does. So this is turbulence, circular, more octaves, different gamma, chips. Pretty cool. Of course, the same randomization rules apply to rotation as well. So we can rotate the instances around any axis, define the minimum and maximum rotation when we're using randomization. Now let's adjust the values a little bit. Let's reset the maximum rotation. Let's change, also reset the translation and change the translation on the Y. And let's use the relative density map. This input controls where our instances should appear or not. We can increase the contrast to get rid of all the scattered items where the texture is totally black. In this video we just scratched the surface of the power of the scatter node in Octane. I'm currently working on another video about scatter that will reveal some important tricks you absolutely need to know about this tool. Stay tuned. Cheers!